Okay, well, welcome everybody. Thank you for joining me today. This is going to be a conversation on how we can bring Gemini to the next decade and we continue to be a leading observatory in science, in astronomy. And I would like to give you a summary of where we are with the instrumentation, what we will have available by the end of this decade, so that we can discuss together what it is needed to make sure that we can support the science that will be available in the next decade with the new facilities that are coming online. And so I can start with this quick presentation. This is just one of the town halls that we are going to have, and the goal is to give you material in preparation for a call for community briefings where we hope to collect your perspective and the desired scientific project that you want to do and what is needed to make sure that you can reach your goals. You have all the tools in hand to succeed in your research. So this is where Gemini is going to be by the end of 2028. And as you can see, there is a number of instruments that have already started to come online, and they are the instruments that are highlighted in bright yellow. And then there are more facilities that will come up in the future. And in addition, we also have a series of feasibility studies that we want to make, we want to conduct to see if we can further expand the capabilities of Gemini. In addition, we are changing the coating of our mirrors so that we can improve the throughput toward the shortest wavelengths. At the moment, Gemini is very sensitive in the infrared. We want to make sure that we can actually be more sensitive at short wavelengths. And we are working into increasing also the tools to support the analysis, not only the instruments, but also the pipeline and the planning tools. So this effort is the result of the previous strategic plan that was released in 2019. And it was written in response of the rapidly changing astronomical landscape. And yet, even if it's only a few years since we released this plan, we already have a number of changes in that have occurred. First of all, Gemini joined the NORLab. So we can now take advantage of all the infrastructures, all the services that NORLab can offer us, and also we can better coordinate with the other observatories in the US to make sure that we can be more flexible and also have a better collaboration. We got the recommendation from the decadal surveys and all the wide breadth of studies that they bring for both ground-based and space astronomy. And finally, the launch of James Webb was much more successful than we were hoping for. And so instead of having a 5, possibly 10-year mission, we have a very good probability of having actually a 20 to 25-year missions. So much broader opportunities for new discoveries and a better understanding of exoplanets, high redshift galaxies, and so on. So where can we go? How can we use all the tools that are coming online to really fit into this new scenario? To answer this question, I'm going to give you a quick review of how we can use the various instruments in different science cases, starting from time domain and multi-messenger astronomy, that is going to be a major effort in the next decades. And I apologize because I forgot to add SCA. But definitely, we will have a lot of information about all transients that will be enabled by the LSST mission in Rubin, by the Roman Space Telescope, and then all the results that will come out from the gravitational waves campaign that will come from the LIGO and LISA consortium and other events. In general, the transient universe is going to give us information about the dark matter and dark energy, will allow us to better understand the near-Earth asteroids and the Kuiper belt objects, detect transient events like supernovae, gamma ray bursts, and gravitational lensing, and of course, study the optical counterpart of the gravitational wavelengths that are detected, as I was saying, by the various collaborations that are starting now. So in this scenario, Gemini is working to improve the calibration pipeline. We are building a new calibration pipeline that is written in Python and is going to support all the new instruments that are coming online. We are also being incorporated in the astronomical event observatory network so that we can have a fast response to the various triggers, and we can make sure that the best observatories for the specific event is going to observe the target as fast as possible. And finally, we are upgrading the instruments. And in particular, for time domain, major role will be played by Scorpio at Gemini South and the Girmos at Gemini North. Scorpio is going to be an 8-channel imager and spectrograph that can simultaneously collect observations in 8-band over a 3x3 arc-minute field of view. The science goals are to characterize the spectral energy distribution evolution of a transient event, but also monitor in multi-wavelengths variable stars and binaries, and characterize the electromagnetic spectrum of the counterpart of gravitational waves. And in particular, we already know that, for example, the mergers of binary neutron stars can light up the entire electromagnetic spectrum. And so it's important really to characterize these objects at all wavelengths. The particular capability that makes Scorpio so efficient is the fact that the 8 channels can have specific observations times tailored for the various wavelengths, and so we can make sure that we have the optimized signal to noise at all wavelengths. Girmos is going to be a pathfinder for the US ELT. It is a multi-object IFU that covers a 2x2 arc minute. It can also operate in imager mode, covering an 85 by 85 arc second field of view. It is fed by multi-object AO, and we can observe 4 targets at a time with a spatial resolution of 0.025, 0.05, and 0.1 arc second per spaxel. The field of view of the various IFUs can vary from 1 to 4 arc seconds, and the wavelength coverage goes from 0.95 to 2.5 microns. And of course, an ideal target for this type of study is, for this type of instrument is characterized in the evolution of the galaxies over the cosmological time, and investigate the mergers of high redshift galaxies in dense clusters. But also, if you are, like me, a person who likes star formation in nearby star forming regions, then you can characterize the resolved properties of young stellar object in class 1 and class 2. And you can really separate the individual components given the spectacular resolution that this instrument is going to have. Time domain astronomy is not the only field where Gemini can strongly contribute. We see that there are a number of new discoveries enabled, for example, by Webb, but also ALMA and other observatories, in particular in terms of planet and star formation, in galaxy evolution, and understanding what are the conditions that can lead to the formation of planets that can sustain life. So in this regard, we see that there is a lot of going on in the in other observatories. Not only Webb and ALBA are already revolutionizing the field, we are going to have the ELT and the US ELTs coming online in the next decade. We are going to have the next generation VLA. But also for exoplanets, we are going to take advantage of the coronagraph on the Roman Space Telescope, and then we're going to have a plateau that will add new discoveries to what TESS is enabling. And finally, at the end of the next decade, hopefully we will have the HWO that will be a major upgrade in what we can do in terms of astronomy. So in here, the instruments that Gemini can contribute are GMOS and GNIRIS that are already available, and then GHOST that started operation last fall, and iGREENS2 that we are currently finishing to test. We are going to have the system verification campaign in July, and this is an end-to-end testing of the instruments so that we can, from the perspective of the user, so that we can make sure that people can operate the instruments, can collect data, and we're going to offer it by the beginning of 2025A. And finally, we are going to have also GIRMOS available that I've already discussed. So for what concerns GHOST, GHOST is a very exciting spectrograph. It operates between 380 and 1000 microns. And it has a resolving power of 56 and 76,000. At 56,000, we can have 2 IFUs at the same time. At 76, only 1. But the 2 IFU can be displaced everywhere within 7.34 arc second, and the minimum separation between the 2 IFU is 102 arc seconds. We can also collect sky for better sky subtraction. And of course, this is a fantastic instrument if you are interested in the analysis of the chemical and dynamical properties of stellar populations, if you want to characterize the properties of exoplanet, but also understand the evolution of the intergalactic medium or the properties of core collapse supernovae and the origin of heavy elements. And this was the spectrum that was shown for the first press release when the instrument finished the science verification. We already collected important papers from GHOST, and we had a recent press release that demonstrated the origin of chemical variations on binary stars. For exoplanets, a major role will be played by iGREENS2 and GPI2. iGREENS2, as I mentioned, is going to be offered already this year. It has a very high resolution of 45,000, and it operates in the JHK band, in H and K band. And it is tailored really to cover major molecular bands where we have the building blocks for the amino acid that can lead to life. GPI2 instead is an extreme AO coronagraph. It's an IFU, and it can trace the distribution and relative abundance of silicates and complex molecules across the circumstellar disks. And then you can apply, of course, at different environments to see how local condition can affect the formation of planetary systems. I did not include Maroon-X, which is a visiting instrument, but we are looking at bringing it as a facility instrument on Gemini North, and this will allow us to do extreme precision radial velocities for exoplanets, and so characterize the structures of the planet and their mass and all the capabilities. So to summarize, by the end of this decade, we will have a great upgrades in imaging, spectroscopy, and in particular, in terms of IFUs. These are the various combinations that we are going to have between Gemini North and Gemini South. And I would like to ask you to consider all these capabilities so that you can start to provide us feedback through short, couple of pages, community briefing reports, where you can, for example, tell us how we can pave the path of HWO and ELT, but also what capabilities can really improve the performances of Gemini, and should we, for example, focus on a major new workhorse instrument, or maybe consider having multiple smaller, more specialized instruments that can allow better but more focused science in different fields. And so after this, I would like to open the microphone for conversations with all of you if you have questions and suggestions. Do I have to unmute people or people can unmute? I think that everybody can unmute, right? Grant?
Hi, thank you for that presentation. That was great. My name is Grant Williams. I'm at the University of Arizona, and I'm the director of the MMT Observatory. My research focuses on studying supernovae using polarimetry. I was curious whether you can say anything about G-pol, the idea of trying to do polarimetry at Gemini, and whether that's moving forward.
So I think that we're trying to look into the feasibility studies. Definitely having strong science cases presented by the community and having feedback from the community that allow us to ask for support and make the case. So this is why we're having this conversation, right?
Thank you.
I guess I haven't mentioned that, but it was in the last title, the title of the last slides, that we have this call for brief reports, and we would like for you to provide them by the end of August. We're going to have a mailing address where you can put where you can send your contribution and we will open it in few weeks, a couple of weeks from now. Yes, Eric?
Hi, Elena. Thanks. Very nice summary. For others, I'm Eric Steinring. I'm the head of the Canadian Gemini office. And Elena, my question is that you just said that these brief reports are due end of August. I noticed that the web page which has been shared with the cast says that it's September 14th. Just want to clarify that.
Oh, okay. Then it's September 14th. I'll correct it.
Okay. And also so that the community understands about what is expected in the reports. There's a short description there that these are 2-pagers, and your hope is that this is individuals who are sending these reports, people who are creating their own community to make requests, or do you see these as a broader reports from larger communities? Is that your hope, or what would you prefer?
I think however people like to communicate, it's great. I mean, if people don't want to write a report, but they want to send me a short case, that I also really appreciate. What I would like to see is a science case. I like to study stellar populations because this is what you can learn, and these are the wavelengths that are important for me. So, but once you have highlighted the science case, why what you want to do is important, what do you want to really achieve in that field, what are the aspects in terms of instrumentation or in terms of tools, how we should operate Gemini, and that can really advance that field. For example, the way we support the time domain, maybe it's not the best one. If people have suggestions and ideas, it's something that we are interested in hearing. We know that the time domain community is actually quite well self-organized. They've already provided a number of quite extensive report as a result of conference and working groups. But I'd like to see things coming from large groups or individuals, and I would like to have a broad range of seniorities from who is writing, because right, it will be the telescope that supports those who are now the junior member of the astronomical community, but they will be the leader in 10 years from now. So I want to make sure that they have the telescope that allows them to lead.
And I have a follow-up question. Thank you. My follow-up question is when you have these reports, is the intention is that these will be published, public, and how will you review and make use of these reports? Does it go to the staff, for example?
Yeah, that's a very good point. So we had a community survey in January, and we just finished analyzing the results. We are going to publish the results of the survey. We are going to publish the reports as well, make them available, and we are putting together a working groups with representatives from the various Gemini's partners to collect information from these reports. We will present an initial result of the report to the Gemini board at the end of the year. And then that will become the initial input for the strategic plan for Gemini that will include the science, but also other aspects like how we can our interaction, for example, with the local communities on Mauna Kea and in Chile, and how we can be more respectful of the environment, the impact of astronomy, how Gemini can control that part. So all these areas will be part of the strategic report, and that will be presented to the board, approved by the board, and when that is done, it will be published. We aim at doing it before the Gemini 2025 conference. That will be at the end of next year. So,
thank you.
Mm-hmm. Is there any more questions? I guess if nobody wants to ask more information, I guess we can close the meeting now, and then I will look forward to your input for how to improve Gemini and build the Gemini of the future. Thank you, Nadine.
Thank you.
Bye-bye.
Thanks,
Thank you.
Elena.
Oh, there was a comment in the chat. Bye. Thank you, everybody, for joining.